So you've probably all heard of something called acid rain, and I would think of acid rain as sort of a secondary pollutant. Earlier when we talked about gas pollutants that from anthropogenic sources, we said that burning coal, especially that has sulfur in it, will give you some sulfur oxides. And sulfur oxides can react with liquid water in the atmosphere to form sulfuric acid. Yeesh. So when we talk about acid rain, notice that it's not just limited to rain. We could have acid fog, we could have acid snow. So in general, we call it, instead of acid rain, if you want to catch the fog and the snow, for example, you could call it acid deposition. So again, it's like a secondary pollutant. So it's adverse to life, and it's actually adverse to things too. It can be very corrosive. And if you go online, and maybe in your textbook, you can see pictures of how certain parts of the world that have high acidity in their rain and their fog and their snow, that they have kind of pitted objects that are exposed to that. It can be harmful for life, you might imagine. Breathing in sulfuric acid is not good. It can also have long-term effects on our wildlife. For instance, both plant life and vegetation and animal life. Specifically, Canada, and I'm going to show you here a map in a minute, but kind of the northeast, our northeast, North America, and I guess northeast Canada is North America, isn't it? But the northeast has gotten the brunt of this acid deposition, and they actually have lakes, many lakes, that because of the acid content, they're lifeless. So when we talk about a pH scale, we talk about things being either acids or bases, and the pH scale, basically the middle is 7. Okay, so if you have a pH of 7, that means it's neutral. pH of 7. Now it's a logarithmic scale, so now even though you can have a pH less than 1, usually our pH scale goes from 1 to 14. So you get kind of a sense for this. All right, so tomatoes tend to be acidic, so you're looking at a pH a little higher than 4. Carbonated soft drinks, a little more acidic, pH 3. Lemon juice, a little more acidic, almost pH 2. And your stomach acid is running about a pH 1. So that's very acidic. Again, this is like a logarithmic base 10 scale. So 1 pH unit is about 10 times the one ahead of it and before it. So what sort of things are basic? Well, baking soda runs basic about pH 8. Ammonia runs a pH of 12. The soap, lye, runs about a pH of 13. So keep in mind that as we talk kind of less than pH 7, then it's acidic, all right? The lower the pH means that it's acidic. Now, typically, in kind of our hydrological cycle, we would expect actually our rainwater to be acidic. Remember, 7 is neutral, so pH of 5.6 is acidic. But what we're going to see on the map here in a minute is that we definitely have pHs even lower than the normal 5.6 in kind of our northeast. So here you go. Looks like a bullseye, doesn't it? Where these folks, I don't know if you can tell from the color chart here, but these are pH less than, more acidic than 4.2. Not good. And then the bullseye ring, the next one is 4.2 to 4.4 about, and then this lighter one is 4.4 to 4.6, and then out here we have 4.6 to 5.0, and then this is greater than 5.0. So can you kind of see where these guys look like they get the brunt of it? And we are under the influence of surface winds, the mid-latitude westerlies. And so basically our pollution has kind of gone this direction. The other thing is that historically, when North America, or when the United States was kind of becoming established, this is where they set up shop, over here on our East Coast first. So our industries are more established and over there. And with industry, then you are burning more fossil fuels. Burning more fossil fuels can, among other things, give you acid rain. So taller smokestacks do improve the local air quality, but I have a few slides here in a minute to kind of show you that somebody's got to pay the piper. There's various ways that we can clean up our emissions. One of them is we burn cleaner fuel. Another is to basically try to scrub out the nasties before they leave. So this is looking at another kind of look at pH values throughout the United States. This would be O6 values. So I mentioned that taller smokestacks help to clean the local area anyway of pollution. But intuitively, you think that the wind is going to carry that pollution downwind, and it is. And so the wind actually does a couple of different things. For instance, if we compare this where we have wind running at 5 meters per second versus wind running at 10 meters per second, you can see that you can see that it's carrying it faster here, okay? And then the other thing is that with the faster wind, we can get more turbulent wind, and it can kind of mix with its surroundings. Okay, so again, this is looking at wind traveling 5 meters per second and wind traveling at 10 meters per second. So I think I mentioned a little bit ago when we saw China that it had all that kind of problem with smog in that particular photo. Well, if we have a highly populated area like China with a lot of factories, and they're pumping out the pollution because of their industry, they may kind of, because of things that are outside of their control, like a temperature inversion, they may have their pollution concentrated. If the air is pretty darn stable, then what's going to happen is it's not going to want to rise. We talked about stable versus unstable air. So unstable air will rise, stable air will not rise. So basically then the air that you have is the air that you're going to keep for a while. And if you're polluting it, then you're stuck with polluted air. So temperature inversions are notorious for, or temperature inversion can basically kind of cap this sort of air from rising. Another type of inversion is called a subsistence air inversion. I'm going to show you a picture here in a minute. But basically you have descending air, and as that air descends, it warms, and it kind of, you basically create a temperature inversion. So this is looking at kind of an inversion that can form overnight. So what's happened here, and we kind of talked about this when we talked about radiation fog a little bit, is basically the Earth's surface has petered out its thermal energy. It's going to cool off overnight. I can tell this is night because the moon's up there. And so it basically peters away its thermal energy, and so now it is cold here, okay? And it's got a kind of a pocket of warm air above it, and then we have colder air above that. So this is a temperature inversion, and this can you kind of see where it basically works as a cap. So that cold air does not want to rise, right? So what hopefully can happen then is when the sun comes out, it can clear up that temperature inversion, and we can go ahead and get that smog going on its way. So this is showing you this subsistence inversion. So basically you have maybe an upper level high, and it's forcing air down. you have subsiding air. And as that air is forced down, it warms. Okay, so then what you can do is basically have another temperature inversion. And notice in the picture here we see, the smog being kind of trapped then.